Today we are going to solve the problem 6.13 of Griffith third edition Introduction to Quantum Mechanics. The problem 6.13 consists of two parts. That is the problem 6.13. Consider an electron in a hydrogen atom. Part A is so that if the electron is in the ground state, then necessarily the expectation value of momentum operator P. Here you note down is a bold letter P sub E. E indicate electron. Momentum operator of the electron is equal to zero. No calculation is allowed. Here I am going to explain conceptually why it is going to be zero. The ground state of hydrogen atom corresponds to the first orbit, which is spherically symmetric. The expectation value of momentum is a vector. That is very important. In a spherically symmetric state, there is no preferred direction in space. Therefore, the average momentum must be zero in all directions. So, without any derivation, we can conceptually claim that the expectation value of momentum is equal to zero. Then we will move on to part B. Uh, Now we will see the section P, that is so that if the electron is in an n equal to 2 state, that is first excited state, then P need the expectation value of P need not vanish. A given example of a wave function, for the energy level n equal to 2, that has non-vanishing expectation value of P and compute the expectation value of P for this state. Uh, First, you take the normalized superposition. That is, psi is equal to 1 over square root 2. This is normalization constant. And sum of get 2s plus get 2pz. Since uh, since P equal to E minus E vector R, it is enough to compute Z. So we know we can easily prove this relation using the Hamiltonian. You know the Hamiltonian H is equal to P squared over 2m plus the potential energy V. From this, we can easily prove that P is equal to minus E times the vector R. So, because it's a radial part, is just enough to compute the expectation value of Z. The expectation value of Z is by definition is equal to psi star of R Z psi of R T3 R, because it's a three-dimensional one. So expanding psi and using that diagonal term vanishes by parity. That is Z is add 2s and 2p Z has definite parity. This is diagonal element is zero. That means psi 0 0, psi 1 1, it will go like this. Psi 2 2, diagonal element will be 0. So we need to worry about the non-diagonal element. So we got the superposition of the wave function psi is equal to this one. Here I am going to take the real part of m. M is I am taking this as this term inside the bracket multiplied by half is m. So here only difference is first term and the second term is complex conjugate of each other. So this we can take 2 times prod to s multiplied by get to 2p. Then this 2 2 will get cancelled. You will get 2 times the prod to s and get 2pz. That is the real part of M. So plug in the hydrogenic wave function. We know the hydrogenic wave function. Use the spherical coordinate. In three-dimensional spherical coordinate, z is equal to r cos theta. You know it very well. And for hydrogen, z is equal to 1. So the wave function r to 0, we have solved many problems using r sub to 0. That is n m m r n l m n l sorry, n l m. Here n is equal to 2, l equal to 0. So no need for worrying about m because l is 0. So r20 of r is equal to 1 over square root 1 over 2 square root 2 a naught. This is 4 radius. A naught is 4 radius. A naught power 3 by 2 multiplied by 2 minus r over a naught multiplied by this exponential term e power minus r over 2 a naught. Similarly, R21 of R is equal to 1 over 2 square root of 6 A naught 3 by 2 R over A naught e power minus R over 2 A naught. This thing we have solved so many problems using this wave function. Similarly, the angular part of the wave is equal to y00 is equal to 1 over square root 4 pi and y10 is equal to square root of 3 over 4 pi cos theta. We have solved several problems using this radial part as well as angular part. Now we will carry out this one. We have seen this expression. Now, what is m? This is using Dirac notation. In the integral form, it is equal to integral 0 to infinite r squared dr. Because this in 3 dimension, the uh, the wave function is equal to r squared. We have seen already r squared sine theta t theta T pi TR. We have seen so many times. This is the area in the 3 dimension. R squared sine theta T theta T pi TR. Now I am going to separate this expression into two parts. One is the radial part, other one is the angular part. Radial part here you have r squared and dr. R squared integral between 0 to infinite r squared dr and this angular part r20 y00 r as that is I am using the wave function r two, uh, 20 y00 and instead of z I am replacing z by r cos theta using spherical coordinate. This is z. Then r2 y1 y10 r21 y10 t omega. Now r part I am taking out and this t omega is other than r squared dr. So now you have r here, so r squared into r will become r cube, and you take the radial part, that is r20, r21, r20, r21, tr. So I have completely separated the radial part and this angular part, y00, you have cos theta, y10 t omega. This t omega, I am not going into the detailed derivation. So just I am going to explain how to carry out this integration. You know, t omega is equal to sine theta t theta t pi. If you integrate t pi, you know it's well-known result. You will get two. If you integrate 2 pi, you will get. If you integrate t pi, you will get 2 pi, and all routine thing I have explained so many times. So this value of this integral will become, after applying the limit to minus 3 square root of 3 a naught. Similarly, the second part of the integral, this one, after substitution and simplification, you will get square root of 3 over 3. Now this 3 will get cancelled. So you have minus, and square root of 3 into square root of 3 is 3. Here you have a naught. So the expectation value of z is equal to minus 3 a naught. So we have found the expectation value of z. Then we have to find the expectation value of the momentum. Here I have skipped the complete integration. I have explained how to carry out this integration. If you have any problem in solving this integral, because we have done this type of integration so many times, then uh, inform me to in the comment box. I will give separate lecture how to carry out this integral. So now you take it granted that we can carry out this integral by applying the value R20 we have seen already, R21 also. Similarly, y00 is 1 over square root of pi. This y10 is square root of 3 over 4 pi. So all these things we have calculated. So all these things we got to substitute and calculate, you will get this one. Now we got z is equal to minus 3 a naught. And also we know how to convert this into the momentum. The expectation value of momentum is equal to, we have seen, minus E uh, multiplied by the expectation value of Z. So we have seen this expectation value of Z is minus 3 A naught. You substitute it here. Then minus of minus will become plus, plus 3E A naught along the Z direction. A naught is here, E is here, 3 is here. So Z, this is the expectation value of momentum, which is 3E A naught Z. Now you can see 3 is a number, E also constant, non-zero constant, charge of the electron. A naught is a 4 radius. So everything has positive number. So naturally the expectation value of P is uh, non-zero. So naturally that is, we can simply say the expectation value of PE is not equal to 0. There is no term contains 0 here. Everything is having fixed value. Thank you very much for watching my video and supporting me continuously. Thank you very much.